Bonjour, welcome to Wahsa Distance Education Center's radio Zoom classes. This is MBF3C, grade 11 workplace math, and I am the teacher, Bronwyn Slade. If you'd like to participate live today, you can call us at the Wahsa studio at 1-800-465-7144 or 737-4017. You can listen on the radio at 91.9 FM and also on the television at Bell Express View channel 972. You're always welcome to join us live through the Zoom link, which is available from me, your teacher, and also your DEC. Our classes are scheduled from Monday through Thursday from 2 until 3 in the afternoon, and we are in our second week of our 9-week course. Just so you know what to work to submit for marking, as it'll approach really quickly. The support questions, the ones with the pencil icon, are not for marking. You decide which ones and how many to do. If you understand a concept, feel free to skip. You don't have to do all the work just because it's there. However, if you want more practice, let me know and I'm happy to find you some more practice. The answers are in the back of your booklets, so please check your work just to make sure that you're on the right track. Remember, these are not for marking. Do not submit any part of these questions, even mix in with your key questions. Make sure you're just submitting the key questions. The ones with the little key icon are the ones to submit for marking. So please do all of them, showing all of your work, your steps, and your thinking. This way I can truly understand what it is that you understand and what it is that you might be struggling with. So then how do you actually submit your work for marking? Well, there's 3 methods. The first method is to scan your work and send it in electronically. If you have a device, you can most likely scan your completed work through that device. If you have an Apple device, the Notes app has a scan function, and if you have an Android device, the Google Drive app has a scan function. You can visit my YouTube channel and check out the tech tutorials, which show how to actually scan with both of these apps, or you can also let me know and I'm happy to help you figure it out. And then once you've scanned your work, you can send it either through email to studentwork@nnec.on.ca and CC it to me, bronwyn.slate@nnec.on.ca. Or you can also send it through Facebook Messenger, where my name is B. Slate Wahsa. The second method is to drop your work off in Sioux Lookout. We have an outdoor mailbox at our location 74 Front Street. We're the bright red building next to the post office, and we have a small white mailbox next to our side entrance. The third method is to hand your work into your DEC. Your DEC can either send your work through the Express or fax it to 807-737-1732 or toll-free fax to 1-800-463-7852. Students are also welcome to fax in their work if you have access to a fax machine. If you'd like to connect with me through social media, both my Facebook and my YouTube channel are under the name B. Slate Wahsa. You can friend me on Facebook and subscribe to my YouTube channel, and then you'll get notifications every time I upload one of our radio Zoom classes. All of our radio Zoom classes are recorded, and then I upload them to YouTube within 24 hours of airing. And you can access them there. They're in a playlist called MBF3C, which is our course code. There also are short videos that explain common errors and confusing concepts, things that folks often struggle with are there. So that is a really good place to go and check out if you need some support if trying to figure out something out. If you're making constant error, that's a good place to go and see if there's anything that I've already addressed that might just help you out. Math is a really visual subject, so I strongly encourage you to access the YouTube videos. If you don't have access to YouTube, you can't join me live for the Zoom classes, just let me know and I'm happy to send you a copy of the recordings so you still get the full experience and set yourself up for the most success. If you have any questions or concerns, please reach out and contact me. My email address is bronwyn.slate@nnec.on.ca. My Facebook is B. Slate Wahsa. You can call me at the office at 807-737-1488. My extension is 2209. You can also call us toll free at 1-800-667-3703. My office hours are Monday through Friday, 9 a.m. to 3 p.m., though I teach the last hour of my day, so that is not a good time to try to get a hold of me. All right, we are looking at lesson number 3 today, which is solving and graphing quadratic functions. Our learning goals for today are that you'll be able to solve quadratic equations by factoring and finding the zeros, and you will recognize the zeros of a quadratic equation from the graph. You know that you've met these learning goals because number 1, you can identify the x-intercepts on a graphed parabola. Number 2, you can explain why solving quadratics means y equals 0. And number 3, you can use algebra to factor and figure out what values of x result in y equaling to 0. It's okay if this doesn't make sense. This is what we're learning today. This is our goal for the end. So when will you use this in real life? Well, we are making educated predictions. You might not need to solve quadratic equations in real life. Many folks don't, but being able to predict what something's going to happen by using information that you already have is a useful skill, and that is one of the skills that we are developing in this course and in this lesson. But first, let's activate your brain with some mental math. I'm not a believer in the Mad Math minutes where rote memorization and speed are celebrated. I believe that developing strategies and comfort with numbers is much more important, and so that's what we focus on in our course. So today's brain activation question is 60 subtract 28, and we are using the concept of adjusting one of your numbers to make your numbers friendlier. So with this question, it can be really easy to get this type of question that can get easy to get mixed up. So I'm going to sort of think about it on an open number line. So I have 60 on my number line, but 28 isn't a very friendly number to subtract. So I'm going to instead think of 60 subtract 30 because that is much more friendlier. So I'm going to jump all the way back by subtracting 30, and 30 is half of 60, so that means that I end up at 30 as well. But we can see that I only wanted to take away 28 and I took away 30, which means that I took away too much. So I need to actually go back and add in 2 because I took away an extra 2. So I'm going to actually end up at 32 because when I subtracted 30, I took away an extra 2. So this is why this can be really confusing, is that it's like, well, do I add or subtract another 2? I know that I did something with 2, but did I take away too much or did I not take away enough? And so by doing this on an open number line, it can be a little bit easier to visualize that when you were subtracting 30, because that was a friendlier number, you took away too much. And so that means that you need to add to get back up to how much you actually need. So 60 take away 28 is equal to 32. All right, mine's on. Let's engage in any prior learning that we need to know. In today's lesson, one principle is essential for us in order to make this make sense. And this is the idea that if you take two numbers, for my example, x and y, so it doesn't matter what the numbers are, and they equal to 0, what are the possible values of x or y that would make this true? If I have two numbers that are multiplying by each other and they equal 0 in total, what has to be true about either x or y? So let's think about it. If we have any numbers of groups of 0, so we have 10 groups of 0, we have 3 groups of 0, we have 100 groups of 0, we have 2,347 groups of 0. Doesn't matter, any number of groups of 0, we would have 0. Or if we have 0 groups of any number of things, we have 0. So the key is that in order for this to be true, in order for x times y to equal 0, either x or y has to be 0. One of our numbers has to be 0 in order to make our whole amount to be 0. So that's essential for what we're going to be doing today. So for this, so let's look at a little bit of an example. So if we have x minus 2 times x is equal to 0, so what values of x would make this be true? So we need either, because either we have 0 groups of something, or we have a bunch of groups of 0. So that means that either x minus 2 is equal to 0, or x equals 0. So if x minus 2 equals 0, that means that x has to equal 2, right? Because the only way to get x minus 2 to equal 0 is if we do 2 take away 2, which is equal to 0. Or if we have x equaling to be 0, because x is already 0 in our other options. So we don't have to rearrange that at all. So this is saying that in order for x minus 2 times x to be equal to 0, either x has to be 2 or x has to be 0. So let's check that to see what this actually, if we were to solve from one of these, if we were to use x equals 2. Let's see, if we say that x equals 2, so we have 2 take away 2 times 2 is equal to, well, 2 take away 2 is 0. So if we have 0 times 2, then that's equal to 0, because 0 times 2 is 0, and so that is true. Or if we have x is equal to 0, then we would say x minus 2 is 0 minus 2 times 0 is equal to 0. Is this true? This is what we're wondering. So 0 take away 2 is negative 2. Then times 0, is that true? So negative 2 times 0 is equal to 0, because negative 2 times anything times 0 is 0. And so that is true. So for both those values of x, this works, that our whole equation is true, that either x is equal to 2 or x is equal to 0 makes our whole thing true, that the whole thing equals 0. So this is going to be essential as we continue with today's lesson. All right, so if we have another example where we have x minus 2 and x plus 3 equals 0, the same idea works, is that we have to have x minus 2 either has to be 0, or x plus 3 has to equal 0 in order for the whole thing to be equal to 0. So that means that x minus 2 equals 0 is only true when x is equal to 2. 2 take away 2 is 0. That's the only time that that'll be true. Or if we have x plus 3 is equal to 0, the only time that is equal to 0 is if x equals negative 3. Negative 3 plus 3 is equal to 0. The same thing, we can go through that check again and see if this works out, and you'll see that in both these situations, this makes the whole equation equal to 0. And that's how we solve. That's how we figure out the values of x that make this whole equation to be equal to 0. The other thing that we need to remember today are what intercepts are. So I'm going to be using that language. So here we have two graphs. We have a linear graph, a straight line graph, which you would have looked at a fair amount in the grade 9 course. And then we have a parabola, which is a quadratic graph, which is, you would have looked at a fair amount in the grade 10 course. So both of these have intercepts. And intercepts are where your line, so either your straight line or your parabola, cross an axis. So the y-intercept is where it crosses the y-axis. So your y-axis is your vertical axis. So your y-intercept is where it intercepts your y-axis. I know nothing about football at all, except I know that they intercept a ball. And so it's where the one team cuts and gets the ball when the other team is throwing it. So the sort of idea is that you're intercepting, you're cutting the line, you're cutting the axis. I have no idea if that actually makes sense, but it does to me. Then our X-intercepts are where your line cuts across the x-axis, which is your horizontal axis. So it's really important to be familiar with these words because I'm going to say them, they're going to come up, and you just need to know what it is that we're talking about. So every parabola always has a y-intercept. It doesn't always have an x-intercept. It might have two x-intercepts. It might only have one, or it might have zero. We'll see that a little bit as we move forward. But it's just something that you're going to have to be comfortable about, that your intercepts are where you cross the axis. Okay, so now what are we actually learning about today? We are learning to recognize the zeros on a graph. And this is on page 22 of your IL booklet. So the example that we're going to start with is not a pretty example, and that's okay. Sometimes our numbers are not pretty. But we have y equals 0.25 x squared minus 2.5 x minus 6. So this is a quadratic because our degree of our polynomial is 2. Our highest exponent is a 2, which indicates that we're dealing with a quadratic, which is a parabola. So we can confirm this by making a table of values. And so we make a table of values. We're putting in values. We're choosing values of x and substituting them into our equation. So if we start with -4, we would put -4 in every time that we see an x. We have 0.25 times -4 squared minus 2.5 times -4 minus 6. We calculate that, we're going to get 8. We can plot that on a graph, which I'm showing you here. Then if we do -2, we put that into our equation, we'll get 0. If we put in 0, we'll get -6. We continue to put in values into our equation and we'll get, I do a bunch. If we do 2, we'll get -10. If we do 4, we'll get -12. If we do 6, we get -12. If we get 8, we do -12. X equals 10, y equals -6. X equals 12, y equals 0. X equals 14, y equals 8. And now you can see that I've plotted all those points. We can see that we have a parabola shape. So all that we've done is we've graphed our parabola. We have an equation, we've graphed our parabola. So to recognize the zeros on a graph, what that means is that is where our graph, our parabola, crosses, where it equals to 0, where we cross over our x-axis because our y is equal to 0. So x-intercepts and zeros are, in this context, are the same thing. So if a question asks you to find the zeros for a parabola, they're asking you to find the x-intercepts. It's just different language for the same thing. And that is because the x-intercepts happen when y is equal to 0. So for this example, we can see that the zeros are when x equals -2, because then y equals 0, and when x equals 12, because then y equals 0. And that's the first part of this lesson, is figuring out where those zeros are. So let's practice. We're going to identify the zeros for each quadratic function. So we're going to look at some graphs, and we're going to see where the zeros are. So remember, zeros are your x-intercepts, are where your parabola crosses your axis. So here we have a graph, a parabola, it opens up, and we can see that here, where our red line crosses our axis at -4 is 1, 0, and where our parabola crosses at +1 is our other 0. So you would say, how you would answer this is that you would write zeros Sorry, it seems as though my pen is a little bit off today, which is just awesome. Zeros are equal to when x equals -4 and +1 are the zeros for this graph. This is one of those times that really being able to watch the video is going to make most sense for you. All right, second example, we have another parabola. Here, my eye is drawn to this point up here but that point is actually the y-intercept. We're talking, our zeros are where our x-intercepts are, right? So here, where x is equal to 2 and 6. So our zeros are x is equal to 2 and 6. Next example, here our intercepts are at 0 and 7. So our zeros, you could also say your x-intercepts, you don't have to call them zeros, it's okay. Either whatever makes most sense, is 0 and 7. You also could do them separately. You could say x is equal to 0, x is equal to 7. That's different notation, that's fine too. But as you can see from a graph, it's fairly straightforward. You just look at your graph and you figure out where your graph is crossing your axis, your x-axis. All right, for our fourth example, our parabola here is just sitting on our x-axis. So we only have 1, 0. There's only one point where our parabola crosses our axis. And this point is where x is equal to 5. So we only are, when your parabola sits on the x-axis, there's only 1, 0. Here we have a parabola that's opening down, but we can still see that we have 2 zeros because it still crosses at x is equal to -3 and -2. And then finally, we have a graph where our parabola does not touch our x-axis. We do not cross the x-axis, and so there are none. In this example, there are no zeros because for no values is it true that if x is equal to a number, that y is going to equal to 0. It never happens for this parabola because it's above the x-axis. It never crosses the x-axis. So that is a possibility. Remember how I said you could have two two zeros, 1 0, or no zeros. So those are some examples of what those would look like. And that's how you identify your zeros from a graph. Okay, so then how do you actually do this without graphing? And now we're going to go back a little bit onto page 20 of your IL lesson. I don't always like to do things in the order that the booklet does it. I did not write the booklet. I like to do things in ways that make a little bit more sense. So for me, visualizing it first, seeing it in a picture, and then figure out how to find your zeros without graphing makes sense to me. So we're going to go back to page 20 in your IL booklet. And now we're going to solve this without graphing, but using factoring, which is what we learned how to do in lesson 2. So 2 things to remember. When we're solving a quadratic equation, it means finding the x values that make y equal to 0. That's what we just did. Remember, we just looked at parabolas and we figured out what x values make our y equal 0, make our parabola cross the x-axis. Second, we need to remember that factoring means finding the terms that multiply to be our product. So finding 2 sets of terms, 2 binomials, to figure out that equal to our trinomials. See why we have to remember that. So for example, we have y equals x squared plus 3x minus 10. So we're going to step 1, we're going to think back into what we just did and remember that we are looking for our values that make our whole thing be 0. We want our whole equation to be 0. That's what we are looking for. because our intercepts happen when y is equal to 0. So we are going to set our equation to be 0. So instead of it being y equals x squared plus 3x minus 10, we're going to say 0 equals x squared plus 3x minus 10, because we are looking for the moment of this graph when y is equal to 0, when our parabola crosses the x-axis. Then step 2, we want to remember that factoring means that we are finding the terms that multiply to be our product. And if we think back to what we did in our minds on today, we know that if we have two numbers, a and b, and they equal 0, that means that either a or b must equal to 0 in order for this whole thing to be true. And so we can use that fact to figure out what our actual values are. So what we're doing is we're solving for x, but because we have an x squared term and a 3x term, we can't just rearrange this and solve it like we usually do. We have to use factoring. So for step 2, we're going to factor, and we're going to say, so I skipped the steps of factoring. I just factored it. I didn't write out the steps. So I'm saying that 0 is equal to x plus 5 times x minus 2, because, so this is just factoring like we did in lesson 2. And I got my 5 and my 2 because 5 times negative 2 equals negative 10, because I needed two numbers that equal to negative 10, and they add to be positive 3. Sorry, my writing is really messy today. 5 plus negative 2 is equal to positive 3. So that's why I factored. That's how I got that information. I'm not going to break down all the factoring today because that's what we did in lesson 2. You should be comfortable with that so that we can apply it now. So what that means, if we think about what we talked about today in our minds on, that x plus 5 either has to equal 0 or x minus 2 has to equal 0 in order for the whole thing to equal 0, in order for x plus 5 times x minus 2 to equal 0. So the only way that x plus 5 is equals to 0 is if x equals negative 5, or the only way that x minus 2 is equal to 0 is if x equals 2. And so we've solved for x. We figured out what x's, our two x values are that make our whole equation 0, which means that we found the x-intercepts. So then let's just look to see, does the graph give us the same answer? Does this make sense? Because the graphing maybe makes a little bit more sense. So if we graph this, and I'm using Desmos, is a program, an online program that you can use that graphs things. So those are where my images come from, and I'll link that in my show notes. There's a free app as well as an online platform. Sorry, I forgot to say that earlier. So you could actually use this, which is it's a great tool. So I put in y equals x squared plus 3x minus 10 into my graphing software, and it came up, it gave me my parabola, and I can see that my x-intercepts are negative 5 and positive 2. This is where the 2 points where my parabola crosses my x-intercept, and that is what I was able to solve with factoring. So hopefully that makes sense. That is the basic premise of this whole lesson. But sometimes your equations look unfamiliar. They don't come in that easy, obvious arrangement where you just need to make it equal to 0. So if it is unfamiliar, we need to, here I don't have a y to substitute 0 in for. Here, from this example, I have x squared plus 8x equals minus 12. So I can only replace a y for 0, because that's what it is. I can't just say that x squared plus 8x equals 0. I can't do that, because then what happens to my minus 12? So I can't just do that. I want it to be 0, so that means that I need to rearrange what I have in order for it to equal to 0. So I need to go back to my fundamental algebra. And so if I have x squared plus 8x is equal to negative 12, I want to get this negative 12. I want all my terms to be on the same side of my equal sign. So what I'm going to do is if I have negative 12, I'm going to add 12 to one side, which means I'm going to add 12 to the other side. So negative 12 plus 12 is equal to 0, which is what I want. So now I have x squared plus 8x plus 12 is equal to 0. And now I can factor just like in lesson 2, and I can figure out my x-intercepts are from there. So sometimes you need to rearrange your equation in order to make it such that it's equal to 0. Another example, I have x cubed plus 5x squared plus 4x is equal to 0. Well, this is not a parabola, right? It's got a cubed. So that doesn't work, but I can still, but if I look at it, I've got x is in each of my terms, so I can common factor x out. So if I common factor x out, I'm left with x squared, because x times x squared is x cubed, plus 5x, because 5x times x gives me x squared, plus 4x, sorry, but plus 4, because 4 times x gives us 4x, is equal to 0. And now you can, this part that's inside of your in brackets, you can factor that and get your two binomials and your solve for your x values. You're going to end up with 3 x's. You're going to end up with x. Here, let's just do it quickly. So what are two numbers that multiply to be 4 and add to be 5? Well, positive 4 and positive 1. So we have x times x plus 4 times x plus 1. And so that means that either x is equal to 0 or x plus 4 is equal to 0 or x plus 1 is equal to 0. And so that means that we have x is equal to 0, negative 4, and negative 1 are our zeros. This is actually a cubic. It has 3 roots, 3 zeros. So don't worry about that, but you can still do our same steps. Then here I have 2x squared plus 6x plus 4 equals 0. Again, we always want a common factor first. We can see that I have a factor of 2 that is common to each of them. So I'm going to factor out 2. So I get 2 times x squared plus 3x plus 2 is equal to 0. And then you can now factor the x squared plus 3x plus 2. If you were trying to do 6x, finding two numbers that multiply to be 4 and add to be 6, you can't do that because you have this 2 at the front. Remember, you have to common factor it out first if you don't have a 1 at the beginning or just an x squared term. And so that's what you can do when it doesn't look super familiar. It most likely is. You just need to do a little bit of work first in order to get it to the form that you want it. All right, and now you're able to do your support questions on page 21, questions 1 through 4, and on page 23, question number 5. All right, so let's do some more practice questions just because this is weird. So identify the zeros for each quadratic function. So number 1, that's what we've been doing. That's what you're doing over and over again in this lesson. So we have b squared plus 5b is equal to 0. So it already equals 0, so we don't have to rearrange it, or we don't have to remember to put it equal to 0. All we need to do is factor. So if we look here, we can see we have b squared plus 5b. Well, I can only have 2 terms, but I can see that b is common to both. So I can see that b times b plus 5 is equal to 0, because b times b is b squared and b times 5 is 5b. So now I have either b is equal to 0 or b plus 5 is equal to 0. Well, b is equal to 0 is done. I don't need to do anything with that. And b plus 5 is equal to 0 is equal, b has to be equal to negative 5. And so our zeros for this quadratic are b is equal to 0 and b is equal to negative 5. All right, number 2, we have t squared equals 11t minus 28. So this isn't, we don't like this because we have our t squared term on one side and our other terms on the other side. We want everything to be on the one side. We also want positive t squared term. This is going to make your life so much easier if you have a positive t squared, because then you don't have to factor out -1, right? If we only know how to factor if our value is a equals 1, if our coefficient of our squared term is 1, -1 does not count as 1. So my life is going to be a lot easier if I move all of my terms over to my t squared side, even though I have 2 terms. It's just going to be better. So how I'm going to do that is I'm going to do t squared is equal to 11t minus 28, but I want to get rid of 11t. So the opposite of 11t is if I take away 11t. So if I do it on one side, I have to do it on the other side. So now I have 11t squared minus, sorry, t squared minus 11 equals 11t minus 28 minus 11t, right? So that crosses off our 11t or cancels off. So we're left with, sorry, I forgot to write the t. T squared minus 11t is equal to -28. So I want to get rid of that -28. So I'm going to add 28 to both sides. Remember, we have to do it to one side. If we do it to one side, we have to do the other side to keep it balanced. So I end up with t squared minus 11t plus 28 is equal to 0. And now that all of my terms are one side, I can factor. Do I have a coefficient of 1? Yes, I do. My t is 1t squared. So that means I can just look to see what are 2 numbers that multiply to be positive 28 and add to be -11. You could list your factor pairs if you wanted to. I just know that 7 times 4 is 28, and -7 times -4 is -11. So I know that my 2 things are going to be -7 and t minus 4 is equal to 0. It is really, really easy to get your signs wrong. If you get your signs wrong earlier, up here, maybe, up here you get your signs wrong, then you're going to get your signs wrong down here, and you might get your numbers wrong too. So it's really, really important to be really careful with what your signs are and really paying attention to that. So then I have t minus 7 is equal to 0, or t minus 4 is equal to 0. So t is equal to 7, or t is equal to 4. Those would be my 2 x-intercepts for this question. Number 3, we have k squared plus 15k equals -56. So again, we want all of our terms on the one side of the equation. It doesn't matter which side it is. I just want to have them on one side, and I'd like to have a positive squared term. So I could do it on either side. It doesn't matter. So I have this -56 that I want to move over. So if I'm subtracting 56, if I have -56 on one side, in order to cancel it off, I'm going to add 56. If I add it to one side, I need to add it to the other side. They cancel and give me 0, which means I have k squared plus 15k plus 56. And now we've set it equal to 0, and now we can factor. So we're looking for 2 numbers that multiply to be 56 and add to be 15. Again, you can list your factor pairs off. This isn't a 56 isn't a super friendly number, but because I have my timetables memorized, I know that 7 times 8 is equal to 56, and 7 times 8 equals 15 if I add them together. So I know that it's going to be k plus 7 times k plus 8. It does not matter if I were to write k plus 8 times k plus 7. The order doesn't matter if they are both positive. The sign does matter if it's -7 or if it's -8. That would change it, but if they're both the same sign, the sign only has to go with the number that is a negative number and a positive number, not the same thing. So that means we have k plus 7 equals 0, or k plus 8 is equal to 0. So that means that k equals -7 or k equals -8. Those would be my two zeros for this quadratic function. Again, lots of people mostly make their mistakes at this step when they are rearranging their equation, which isn't something that is new for this course, but it might be something that you haven't done in a long time. And making mistakes with your signs here is the other place that people make errors. So be really careful with your signs and practice rearranging your formula or your equations. If you need more practice, if you want to talk about that, let me know. All right, so then let's do some word problems because people love word problems. They can be really confusing, so it's important to practice them. So number 5, the height of a flare fired from the deck of a boat in distress can be modeled by h equals -16t squared plus 96t plus 112, where h is the height of the flare above the water and t is the time in seconds. When does the flare hit the water? So we don't have to draw this, but just visualizing it can be good. So I have a boat, a beautiful boat, and I have some water, and I've shot a flare, it's gone up, it's come down, and I'm trying to figure out when it hits the water. So my time is like that, and my height is like this. If you want to even think about it on an axis, you could. So just sort of visualizing what's going on helps us understand a little bit what is happening, what we're likely to get. But basically, if our water is our horizontal axis, that is what we're trying to figure out. We're trying to figure out when water hits the water, what is that point? What is that 0? Because our 0 is when our height is 0, that's when the flare has hit the water. So that means we have to use our formula. So h equals -16t squared plus 96t plus 112. And our height is equal to 0 is when our flare hits the water. So we can put h, instead of h, we're going to put 0 equals -16t squared plus 96t plus 112. Now here we have -16t. So that means I need to factor out -16 because it's not 1. So -16 is going to, if I factor that out, I'm going to be left with t. Now, I don't know what 96 divided by -16 is. So what I'm just going to do is I'm going to do it on my calculator, on my Desmos scientific calculator. I do 96 divided by -16, and I get -6. So that means that I'm left with -6t, because -6t times 16, -16 is going to give me positive 96. So it's totally fine to not know. Sometimes you have to use a calculator. So then I have 112. If I'm factoring out 112 from, I'm factoring -16 out of 112. I do 112 divided by -16, and I get -7. So now, when I'm factoring, I can ignore that -16, and I can just see, okay, so I have t squared minus 6t minus 7. So that means I'm having two numbers to times to be -7 and plus to be -6. So 7 is a prime number. So we either have, so 1 and 7 would give you +7, but I need -1 times +7 could give me -7, or +1 and -7 could give me -7. These are my factor pairs. But which one is going to give me -6 if I add them together? Well, -1 plus 7 is going to give me +6, and 1 plus -7 is going to give me -6. So 1 and -7 are my two numbers that are going to work. So I have t plus 1 times t minus 7 are my two options. And so now I say, okay, well, that means that either t plus 1 is equal to 0 or t minus 7 is equal to 0, which means that t is equal to -1 or t is equal to 7. And now having answered the question, maybe let's go back and see, when does the flare hit the water? Well, t is my number of seconds, right? So does t equal -1? Does that make any sense? Nope, not possible. Because in real life, we're not going back in time to before I shot the flare. That doesn't make any sense. So that means that the flare hits the water 7 seconds after being shot. And there we go. We've answered the question. All right. And then we have one last word problem. So a garden is number 6. A garden is to be surrounded by a paved border of uniform width. Write a simplified expression for the area of the border. So this is one of those things that's like seems completely arbitrary, but we've got a picture. So if you didn't have a picture, or draw yourself a picture. But here we see we have this green area is a garden, and it gives us the dimensions. So in one direction, it is 16 meters, and in the other direction, it is 14 meters. And that's our garden area. But now we are making this paved area, this gray space around the green space is our paved border. So it's like a walkway around our garden, and it's of uniform width. So the whole way around, it's X, which is what it shows on our diagram. So we wanted a simplified expression of the area of the border. So how much does this border actually cover? And this feels like it can be kind of tricky because it's this little strange rectangle with it's a rectangle with a rectangle cut out. So what we're going to actually do is we're going to think about it as a rectangle, take away a smaller rectangle. So we're going to have a rectangle big and a rectangle small. Because if we take the area of the whole big, huge rectangle and we subtract just the area of the little rectangle, we are going to be left with the area, the gray area around it. So the area of the big rectangle first. Well, we're looking with rectangles, right? So we have length times width. So let's see. Our rectangle is going to be X plus 16 plus X, because there's an X on both sides, right? Because it's X all the way around. And then that's our width, and our length is going to be X plus 14 plus X. So that means that it's really 2X plus 16 times 2X plus 14. And then our area of our small rectangle is equal to just 16 times 14. So the area of the border is equal to the area of the big, 2X plus 16 times 2X plus 14. Take away the area of the little, which is 16 times 14. So we've figured out an expression, but now we need to simplify it. So now we need to make it as simple as we can. So we've got two binomials multiplying by each other, so we're going to have to multiply them out. So 2x times 2x is 4x squared. 2x times 14 is 28x. 16 times 2 is 32x, sorry. And 16 times 14, that one I don't know in my head. 16 times 14 is equal to 224. So 224 is, and then we have then we have to subtract 16 times 14 again, which is 224. So if we simplify it, we have 4x plus 28x plus 32x is going to be 60x. Hey, that's the same question, reverse our question of our brain activation. And 224 take away 224 is 0. So now we have a simplified expression of our area is 4x squared minus 60x. And then to finish this off, so part B, the border is to have an area of 216 meters. Find the width of the border. So we're trying to find the x. So here we know that our area is equal to 4x squared plus 60. So because I know my area, I'm going to put that in. 216 is equal to 4x squared plus 60x. And now I'm going to be solving for x, right? So I want to subtract 216 from both sides. So we get 0 is equal to 4x squared plus 60x minus 216. So I'm going to factor out my 4 to get 4x squared plus 15 minus 216 divided by 4 is equal to 54. So then to factor, I'm looking for two numbers that multiply to be negative 54 and add to be positive 15. Well, I know that I was going to say that I know that 9 and 6 make 54, but that's not going to give me positive 15. So if you don't know, then sometimes you need to figure out. So 54 divided by 12 is equal to 4.5. That's not going to work. 15, that's not going to work. I can't think of what 54 divided by is going to be, what my right number is. So because we are running out of time, I'm not going to finish this question. We are going to consolidate because we only have a minute left. So something to work on to see if you can figure that out, because I ran out of time to think. So for our lesson today, we were solving quadratic equations with factoring. Remember that solving quadratic equation means finding the x values and making them equal to 0. Factoring means finding the terms that multiply to be a product. That's key. And then remember that you're recognizing your zeros on the graph and that your zeros are your x-intercepts. And that's all you need to do. So hopefully you can identify the x-intercepts on a graph parabola, and you can explain why solving quadratics means y equals 0. And you can factor and find what values of x means y equals 0. So hopefully you're comfortable with all of that. If you have any questions, please reach out and give me a call. My number at the office is 807-737-1488, extension 2209. You can send me an email at bronwyn.slate@nnec.on.ca or connect with me through Facebook at bslatewahsa. This lesson and all of our other lessons are up on YouTube, where my channel is bslatewahsa as well. Thanks so much for joining me. Have a great day, and I will talk to you soon. Miigwech.